Welcome to BKSS Academy. I hope you are doing great. Now we will discuss about instruction format in computer architecture. Instructions are written in machine languages. Instructions is an order given by user to computer that tells CPU what to do, which instruction to be executed. That is the order by the user to the computer. So the diagram is like this: CPU, and this is the memory. Program counter is 1008. Then this is the information register, instruction register. So 1008 is going to the memory, that is, then it is fetched for the processing for this 1008 location. One by one will be fetched from memory stored in instruction register. After execution of output will be displayed to the user. Instruction format describes internal structure of instruction. That is opcode, address operand, and mode. Opcode means any kind of operation, address operand is value, and mode is how CPU will reach at address of operand, whether memory or register. These are of three kinds. These are of four types, that is 3 address instruction, 2 address instruction, and 1 address instruction, and 0 address instruction. 3 address means opcode, address 1, address 2, address 3. 2 address means opcode, address 1, address 2. 1 address means opcode, address, and 0 address is only opcode. The 1 address is accumulator, 0 address is stack, and example of 3 address is 2 plus 5 is equal to 7. That means add 2, 5, 7. That means 2 and 5 address will be added and it will be stored at the address 3. Some example of 3 address, that is, we have to calculate a plus b into c plus d. How it will happen? Add a b r1, that means a b addition will be stored in r1. Add c d r2, that means c and d value will be added and will be stored at r2. Then multiply r1 into r2, store in x. This is a plus b into c plus d in 3 address. Similarly, in 2 address, move a to r1, b to r1. Move a to r1, that means a will be stored at r1. Then add b to r1, then b will be added to r1 and stored in r1. Similarly, move c to r2, value of c will be moved to r2. Add d r2, that means c plus d plus r2, that is c plus d will be stored in r2. Then multiplication mul r2 into r1, r2 will be multiplied and stored in r1. Then move r1 to x. Then the result will be a plus b into c plus d by 2 address format. Similarly, 1 address format, load a, that means a value will be loaded into accumulator. Add b, that means b will be added with accumulator and stored in accumulator. Store t, that means accumulator will be stored into t. Similarly, load c, accumulator, value of c will be loaded into accumulator. Add d, that means d plus accumulator will be stored in accumulator. Then multiply t, so t into accumulator will be stored in accumulator. Then store x, what will be the value of accumulator, that will be transferred to x. that is b. So result will be a plus b into c plus d, which will be stored in x, that will be the one address instruction. Similarly, 0 address, push a, top of the stack will be a, push b, top of the stack will be b, add, top of the stack will be a plus b, push c, top of the stack will be c, push d, top of the stack will be d, add c, c plus d will be the top of stack. Then multiply top of the stack c plus d into a plus b. It will be automatically multiplied and it will be stored in the top of the stack. So pop x, so top of the stack will be popped to the x, and x will contain the value, that is a plus b into c plus d in the 0 address format. Thank you.